Hey, how you doing? My name's Elton. Welcome to Learn Docker in a Month of Lunches. This is episode 10, and today we're going to be talking about continuous integration pipelines, where everything in the whole stack is powered by Docker. So building and testing applications with Docker and Docker Compose. This is the final episode in what is week 2 of the book. So we'll be looking at distributed applications. This is more of a kind of a practices kind of chapter. So the chapters kind of cover different topics like the technologies that we're dealing with, your Docker files and your Compose files, architecture of your applications, and then practices, kind of daily practices. And this is more of a practices chapter, talking about pipelines, how you can run your infrastructure, so your build server, your Git server, your registry server, all locally in containers, and then what your Docker Compose file looks like and what your Docker files look like to build and publish your whole application stack using just containers. So that's what we're going to be doing today. So let me flip over to my slides. So usual format, if you're new to the series, then this is what we do. So I start with a quick walkthrough of diamol.net, which is the homepage for the book. So that gives you a whole bunch of links that you can follow, find out what this is all about, and find out links to all the previous episodes. The focus for each episode is one chapter, and today it's chapter 11 of the book, which is building and testing applications with Docker and Docker Compose. And then there's Q&A. So if you've got any questions, put them in the YouTube chat. If you prefer to put them in Slack, put them in Slack during the day or during the session. I'll try and do sort of 50 odd minutes of the episode and then come to Q&A at the end. If there's anything interesting to talk about, I will talk about it. Okay, so let's get going. So we're going to start off by looking at the DIAMOL.net website. So this is just the homepage for the book. There's all the links here to buy it from Amazon, to buy it from Manning, who are the publishers. There's a 40% off code there if you haven't got the book yet. Click on that link. Get it from Manning, get it a bit cheaper, or if you're an Amazon Prime user, by all means go and get it from Amazon. All the source code, so the demo application code, all the Docker files, all the Compose files, it's all on GitHub. So like, if you don't want to buy the book, that's fine. Watch the series. Follow along with the exercises by cloning the repo on GitHub. There's also a Slack channel where I hang out, so you can ask me questions if you want to ask me anything, preferably to do with containers. This is the most recent episode is always on that link, diamol.net/stream. And then there's usually a giveaway. So during the live broadcast, which is September 2020, I've got 5 copies of the book to give away every week. Click on that at any time in the future, and you may or may not be lucky. There may be a giveaway because Manning often give me things. The sequel to this book is called Learn Kubernetes in a Month of Lunches. So really, if you're interested in using Kubernetes in production, then really you need a solid understanding of Docker. So by all means, follow through these episodes. And when Learn Kubernetes in a Month of Lunches goes live, which will be early 21, there'll be another series walking you through every chapter of that book. There's a little elevator pitch for the book. Here's the links to all the episodes. So we're just coming to the end of week 2. So episode 10 will take us to the end of week 2, which is all about distributed applications. And the next week we're moving on to more complicated and fun stuff. And there's a little bit about me. So I do freelance consulting and training. So if you've got an interesting project that you want me to help out with, or you want me to do a health check of where you are in your container journey and how to get to where you want to get to, like little short-term contracts where I can come in and help you out, that's kind of what I do. Okay, so as well as obviously doing all this stuff. So okay, let's get on with the chapter. So I think that's enough. That's enough of the sales pitch. So today, chapter 11, we're coming to the end of the second part of the book. This is all about kind of understanding what the workflow looks like. So we're going to be using Docker to run all the tools, to build all the applications, all that sort of stuff. But really, for this chapter, Docker is just the enabler for the pattern, the very DevOpsy pattern that I have this pipeline. That's the heart of my project. So automation is all the way in there. So jobs and because Docker fits so nicely with that structure of having an automation tool that runs a bunch of scripts or whatever you're doing, everything we've done in Docker can be done with the command line. So you can script that all up. You can put that in an automation tool, and you can schedule things to happen like on a daily build or whenever code changes. I've talked in previous episodes about the importance of optimizing your Docker files, optimizing your image builds, and this is one of the reasons. So ideally, as part of your project, whenever anyone changes code and pushes it to the source code management system, that will trigger a build. That build needs to be fast, it needs to be reliable, and the output needs to be something that is clearly identifiable from that build. And that's what we'll look at today. So in the old days, and this is probably showing my age, I've done this role of being the build manager on a large project in like an enterprise environment, and it's kind of a full-time role because in the world before containers, you had a build server or a suite of build servers. They all had to be kept up to date with the same software. You had a whole bunch of projects that had to be managed, so you kind of owned those for the teams, and like it was effectively a nightmare. And it's much more fun not to have to do that. And the containerized CI process, the containerized pipeline, is so much simpler, and all the pieces of the pipeline live in source code. So it's not like there's one person who owns the build server and owns all the job definitions, and only they can make changes. Anyone in the team can fix builds and enhance the builds to add new stuff. So that's what we're going to be talking about. Okay, so if you're not familiar with this whole idea of CI, then anyone makes a change, they push a change to your GitHub or your local Git server or a team foundation or whatever you're using, and that triggers the build. And then some sort of automation server is watching for changes, and it runs a bunch of scripts when a build happens. We'll see all that in action in this episode. And what Docker brings to this approach, there's two things. One, you can run your tools in containers, so it becomes super easy to spin up your own build infrastructure. Whether you do that permanently or whether you just do that as a backup option, it's really useful to know how to do that. So I'll be showing you how to do that. And then the build process itself is slightly different because you're going to be using containers throughout. So as an example here, this is what my pipeline looks like. The CI job gets triggered. There'll be a nightly build as well as regular build when someone changes code. And then the pipeline gets kicked off and it fetches all the latest source code. And then it goes through all these stages. So there's the build stage where it builds Docker images. So like way on early in your Docker journey with this series, you learned about multi-stage Docker files. You learned about a system where you do a Docker image build and it compiles your source code using an SDK image, and then it packages the binaries into your final application image. And what you get is you can build that software anywhere. You don't need to install a bunch of tools on a machine to be able to build it. And in your CI pipeline, that's fantastic because your dependency for your CI server is just Docker. And so you can download the code, you do a Docker image build as part of your pipeline, and everything just works. And then you do the test stage. So the test stage, you're going to spin up a bunch of containers. So you'll create your containers, then you'll run some tests. You can run your tests inside a container that talk to the other containers. It's all super lightweight. So as part of your build process, you can run your smoke tests. All the containers are super fast. The tests run very quickly, and you get your output. You get a solid output. And then if you want to, as part of a nightly build, you can have more extensive end-to-end tests that actually flex like complex workflows through the system to make sure there haven't been any breaking changes. And then the publish stage is going to look something like taking my images that I've built in my build server. I've run my test containers, so I'm happy that they work. I'm going to push those images to my registry. So typically, you may have a situation where, and again, we covered this in the registry episode, if you're typically going to work with several registries. So I might have a local registry that I use for all my build output. So I've always got a copy of every build that I run. Every build, every Docker image will be tagged with a build number, and I can always run my application from any build. But when I know the build is good and I'm ready to publish it, then it goes to Docker Hub, or it goes to my Azure Container Registry, or wherever the final kind of production source is for good builds that are known to be a potentially deployable artifact. Okay, and then there are more stages beyond that. So this is the simple thing. This is really the CI part. Of course, there's the continuous deployment that comes after that, and we'll cover that later in the book. So today it's all about just how we build our code, how we build up this pipeline, and how we push all the hard work down to Docker so it'll run in the same way everywhere. Okay, cool. So that's just the first. We're only on page 1, so we need to go a little bit faster. So every step in this CI pipeline will happen with Docker and Docker Compose. So everything that we do will be scripted out using Docker files and Compose files, and every step will run inside containers. So that's the kind of premise. You don't need anything to work along with this. And we're gonna have a completely Dockerized infrastructure. So you probably wouldn't do this in production. So certainly for this book, all my builds are done on my local kit in my office. But for the Kubernetes book, I use GitHub Actions. The Kubernetes book, everything is Linux, so I can just use GitHub Actions. They give me a Linux server with Docker on. Again, I've got the same approach. So I've got my Docker files, I've got my Compose files for tests, all that sort of stuff. But when I want to build for this book, because I build Windows images and I build Raspberry Pi images, I bring all that in-house. So there are valid reasons why you want to run your own infrastructure. Plus, if you're a bit of a geek, it's quite nice to have all this stuff running, to have your own Git server. So, if you lose network bandwidth, that's fine. If something goes wrong and, someone in the road cuts through your cable, you just spin up your own Git server and everyone's still working. So it's nice to have it as a backup option. And you don't have to be fixed with one thing. One of the practices that I'll kind of go through in this episode is breaking up your build definition into reusable chunks. So you have a set of scripts that define the steps of the build, and then in this episode we'll put those scripts into a Jenkins file and we'll run the build with Jenkins. But if I wanted to move to GitHub Actions, all the core logic is in those scripts, so I would just run a GitHub Actions workflow that called those same scripts. So it's about kind of being modular and being able to reuse components. Okay, so we're on to page 2, so we're getting better. So first of all, I'm going to run all this stuff. So as I say here, this is not necessarily what you're going to do in your production environment, but because no one wants to manage their own infrastructure stuff, and you will get GitHub for free, you get Docker Hub for free. But this is just showing you that there's an alternative that you can use, maybe in a small team environment. Maybe you're just getting started with this stuff. Maybe you're in a corporate environment and you don't have access to all these great third-party components. You can spin this up in your own infrastructure as part of your proof of concept to say, look, this is what the world looks like with Docker, and look how much cooler it is, look how much faster it is, look how much more modern it all is, and as part of your part of your project to prove out that this is the way you should be going. Okay, so let's just go and spin this stuff up. So I'm going to go. I'm in the DIAMOL source code in my terminal over here on the right-hand side. I'm going to do move to the right directory, which is my infrastructure directory. Again, all this is the folder that I'm using is just the clone of the repo on GitHub. So you just follow these examples yourself. I'm going to start a bunch of containers. I'm going to start GOGS, which is a Git server, really simple Git server written in Go. It's up on Docker Hub. Again, I've repackaged most of these things to get the cross-platform options. I'm running Jenkins, which is an automation server, which is like wildly popular. People use it all over the world. Lots of people don't like it, but there are ways to use Jenkins and make it really nice. And I'm going to run my own registry. So all the kind of the core parts of your build infrastructure, I'm going to run them all in containers. I'm in Linux container mode today. There are slightly different compose files, again, because of the file name, the path conventions in Linux and Windows are different. So that's one thing that I can't avoid. So if you're on Windows, you'll run the line below this. And I'm just going to do the standard stuff. So if you saw the previous episode about using about Docker Compose for multiple environments, where I covered like override files and extension fields and all that stuff, we'll be putting that into action today. So if you didn't see that episode and you're wondering why I've got multiple Docker Compose files, then you might want to go and check that episode out as well. That was episode 9. Okay, so everything's up and running. The other thing I need to do is I'm going to be accessing my registry container using a domain name. I'm going to call it registry.local, and either of those commands will add it to your local host file. So when you do a DNS lookup, it'll come to your container. I've already got that in my host file. So there's my registry.local. I added it earlier because you need to be an admin in Windows to do that, so I did it in a separate session. But that's the output of running these things. Okay, so let's clear this down. Check all my containers are running. So Docker container list, and here we go. So I've got my DIAMOL/Jenkins, which is a Java application. It's publishing to port 8080. Nothing new here. The compose files have got a couple of interesting tweaks that we'll see in a second, but I want to show you what the actual infrastructure looks like first. I'm running my registry, and I'm running GOGS, which is my Git server. GOGS is on port 3000, the registry is on port 5000, and Jenkins is on 8080. So it's all up and running. It's all looking good. Okay, so I'm going to browse now to, what am I going to do here? So yeah, the commands are slightly different, so you need to bear that in mind. These are the things you've got running now, and this is the prefix that I'll use for my image tag. So again, way back in the episode about images, we looked at the tag reference, and you put your domain name of your registry server comes first, and that's why we have this this domain name in here. Okay, cool. So what I'm going to do is browse to GOGS, and I'm going to show you how to set this thing up. Now, I've talked about kind of automation and the Dockerfile being where you define your application and all the setup and everything. Some apps are easier to automate than others. So when we go and look at Jenkins in a second, the whole thing is already set up because that's part of my Docker image, and you can see the Docker file that I've used. Everything is automated. So even the definition of the job is there, the admin user credentials, they're all there in the image. So when you spin it up, it's ready to use. GOGS, which is the Git server, not quite so easy to automate. So you'll come to this page when you first start it up, and you just click install. So all the values are set correctly. I can do that much in the Docker file, but I can't automate the whole thing. So when you get here, you just click on install GOGS, and then when we're done, then you need an account. So you click on sign up. Make sure you call your account DIAMOL, Docker in a month of lunches, because Jenkins expects that. But you can put whatever you like in for the rest of it. So I'm using the password DIAMOL. So username DIAMOL, password DIAMOL, and I'm going to be pushing my local copy of the source code into my local Git server, and Jenkins is going to pull the code from there. So these components, the Git server, the Jenkins, the registry, they're all running in containers. And when I push the code into the Git server, that will trigger the whole pipeline, the whole container-driven pipeline. Okay, so let's create my account. Now I need to sign in. So I'm going to sign in as DIAMOL and DIAMOL. So if you haven't used GOGS, like it's really simple. This is it. You start it up in seconds and it's ready to use. You can run it on a Raspberry Pi with a few gigs of RAM and use it for your whole team because it's a pretty solid Git server. It's got a lot of the features that you get in GitHub. So it's got pull requests. It shows you the preview of file types and all that sort of stuff. I'm going to add a repository. And again, this is all in the book. So I'm not making this up. I'm just not showing you the chapter called DIAMOL. Because again, that's the Jenkins build is already set up to pull the source code from this repo. So I'm going to create my repo called DIAMOL, and that's all I need to do. Again, just all the defaults. So I've got this repository. When I work with it locally, I can do a Git remote add. If you're not familiar with Git, it's a really simple way to be up and running and sharing source code. If you download the repository from GitHub, that's the kind of master version. You can push that to another Git server just by adding a new remote. So the remote is a kind of remote server where your code lives and that you share with your team, and your local copy you're going to push and pull from the remote. Okay, so that was a very quick introduction to Git, by the way. So here we go. So that's up and running with GOGS. I've done this. I've done the install stage, and down here I've registered and created a user called DIAMOL. Make sure it's called DIAMOL when you follow through the exercises yourself. And then I've gone in and created a repository. And the repository is called DIAMOL too. So everything is up and running. As it says here, like it's not great to have to do this. And what you will find is if you come to packaging third-party software yourself in containers, you will find this. You will find this with certain bits of software. They're not all built to be automated in advance. A lot of tools are built to be kind of installed, and then they have a manual setup workflow which happens afterwards, and you can't always capture that in scripts and stuff. There are ways around it. I could build the image and then do a commit, which would take my run a container, do all the setup, and then commit that container to an image. But that's not repeatable. So like try and avoid that wherever you can. Sometimes you just can't package things nicely, and you have to think of other ways of doing it. So Jenkins is better. Jenkins is easy to automate with anything. You can you can have script files in the file system in Jenkins when it starts up, and when it sees those scripts, it will execute them. So if you're interested in Jenkins, if you look at the Dockerfile for these exercises, you'll see there's a whole bunch of groovy scripts that create the job, they create the default admin user, and they set up the job to go and look at my Git repository that's running in GOGS. Okay, so if I go and look at, so that's my repository set up. If I now go and look at Jenkins, and again, the user's already created, username DIAMOL and password DIAMOL. So I typed in DIAMOL the other day without putting the .NET on the end, and it's some sort of medical drug. So I didn't read about what it actually does, but I'm just hoping they don't sue me because I don't think I could fight a pharma company with the money I make from my royalties. Okay, so log in, DIAMOL, password DIAMOL, and click on sign in. So you'll see there's already a failed build there. If you're a familiar Jenkins user, this is the view you normally see in Jenkins, like loads of failed builds. The reason it's failed is because when Jenkins started, it deployed this build. The build got triggered because it was a brand new build, and it tried to connect to GOGS, to the Git server, and there wasn't one because I hadn't set up my repository. So that's why it's showing as failed. Okay, but that's what you would expect to see. So if we get down here, that's what this line here is telling you. It failed because there's no code there yet, so it couldn't pull the source code down and run the job. So don't be alarmed when you see that. That's to be expected. Okay, and now what I'm going to do is fix that up. So I'm going to take my local source code, and actually I've probably already done this. Let me have a look. So if I do a git remote add, so this is adding a remote server to my local kind of Git database for the book. I'm calling it local, and that's the URL for my local container. So all this stuff lives inside the container. I'm not using like volumes and bind maps and stuff, so this is all throwaway. So as soon as you've done this, it's gone forever, and that's all fine. It's just an example of how this sort of infrastructure looks in the container world. So I've already added that local, but you'll see that when you do your git remote add, it'll just say okay. If I look at my remotes, scroll this down so it goes over my head. I've got a local setup for my local host, and then the origin is GitHub. So that's the kind of way this thing usually works. So now if I do a CLS, I'm going to do a git push local. and that will take my local copy of the source code and push it to my local server. And this is what I mean by the backup option. So if GitHub went down and me and my team, it's just me, but if I had a team of people working in my office, I could spin up a GOG server in no time at all in a container. I push it locally. I share the DNS name around. This wouldn't be localhost. This would be some server we could all access, and we're all up and running within 5 minutes. It's not a big deal if your managed provider goes down, because you can spin up an alternative in zero time. In fact, it takes more time to push the source code up than it does to get it up and running. The reason it's stalled is because it's asking me for my password. So you will get this depending on the Git client you're using and your operating system. In like Mac and Linux, you'll just get a command line asking you to log in. On Windows, I get this login window that pops up on the other screen. Okay, so that's fun. That's good. It's all done. It's pushed up to localhost. It's created my new branch. If I now go and browse back to GOGS, so same repository, but now if I refresh, like the whole history there. So again, if you're not familiar with Git, the way Git works is that everyone's copy of the source code contains like the whole history of everything. So whoever's got the latest version can push to a server, and that becomes that takes the whole history of the project is in there too. So all my commits are there, here's my branches, here's all the stuff, and again, it's very GitHub like. So it shows you a file preview. So here's the README doc, which needs updating because that isn't correct anymore. Here are the docs, which then go and feed the website. All that stuff is in there. And then today's exercises, we're going to be building from chapter 11, and this is the Jenkins file that the build job is configured to use. So my Jenkins file has these various stages. This isn't a Jenkins episode, so I'm not going to spend a whole bunch of time on Jenkins, but I am going to point out that each of these stages in the build process, let's click the right button here, just calls a script. So it just shells out to a script. So there's no complicated logic inside the build script, inside the Jenkins file. And that's because then I can then move to GitHub Actions or Azure DevOps or whatever and use their pipeline definition, but bring my tried and trusted stages with me because they're in separate shell scripts. Okay, so I think I've jumped ahead of the chapter there, but I'm sure we'll come to that in a second too. So let's close this down. So Jenkins now has got what it needs to run. So if I build that job, it is scheduled to build every time there's a push to the GitHub repo. But because the first one failed, it's kind of gone on pause. So I need to go back to Jenkins, which is here, and open my project and click build now. And what it's going to do, it's going to execute those shell scripts in the build job. They're all in the source code, so we're going to look at them in a second. All they do is like Docker Compose build, and then a Docker Compose up in the test stage to prove that the containers start correctly, and then a Docker push in the publish stage. So each of those stages is kind of a logical separate part of the pipeline. You can see it's kind of building along here. We've gone past the build stage to the test stage. When that's done, it'll push it to my local registry. So it's building inside containers, so using a multi-stage Docker files. It's building the random number application that we've used before with the API and the web container images. The test stage just spins them all up with Docker Compose, and then the push stage pushes them to my local registry. So everything works as expected. This never happens when you first create a Jenkins job, so you can be thankful that I've set this up for you. If you go and look at the logs here, my output's weird. I don't know why that is. If I click on the link, the output that I get in my build job is the output that I see in the command line. So it's really easy to kind of track back, see exactly what's happened. I can see here that it's tagged an image. It's using the registry.local domain name from my registry server, which is running in a container. It's using DIAMOL as the organization name. This is the application name, and then this is the tag. And part of that tag information comes from the Jenkins build job. And this is where the automation pieces really start to fit together nicely, because I can structure my Docker artifacts, the Docker files and the Compose files, to bring in information from where the build is running and add that metadata to my image. And we'll see that in the episode as well. Okay, so that build's worked, which is a novelty for a first Jenkins build. Depending how long it takes, it depends on what you've previously built on your machines. What's happening here is that the Jenkins container, when it runs the Docker commands, it's talking to the Docker engine where Jenkins itself is running. So it's a kind of inception type of thing. But what that means is it's able to reuse the image cache that I've got on my when I do my local image builds. It's just using my local engine, so it's behaving as though it was connecting to a remote server that running the Docker engine, but actually it happens to be that same server where Jenkins itself is running. So let's have a look at this. So this is what I'm saying here. So containers running in Docker can connect to the Docker API and start new containers on the same Docker engine where they're running. So the Jenkins image that I've got already has the Docker command line and the Docker Compose command line installed. So inside my scripts, when I run Docker commands, they run inside the container, but the Docker command line is talking to the engine where the container itself is running. So it's super lightweight. It's super easy to get this stuff up and running. So you don't need separate build engines or separate build servers or anything like that. Everything just runs in containers. Okay, so yeah, it kind of sounds odd, but you remember from earlier in the series that the Docker engine is the thing that runs your containers. On top of that is the API, which is how you manage your containers, and the Docker command line and the Compose command lines are just clients of the API. And so your API can be sat somewhere else, and you can be sending in commands. Okay, the way that happens normally, you don't have to set anything up because by default, the command line talks to the Docker API on your local machine using a private channel. So it uses a socket on Linux, it uses a named pipe on Windows. So the communication between the command line and the API doesn't leave your machine. It's internal, so it's nice and secure. You can actually expose your Docker engine so that external consumers can connect. And we'll see how to do that later in the book. But you can, because I'm running internally, I can use that same mechanism, the socket or the pipe within my container to talk to the engine where the container is running. This will make. Well, I'll just show you when we see the listings. This will make more sense. So here's the diagram here. I'm running my commands on my laptop. I don't know why this is such a big picture. There's no reason for these images to be so massive. And I send my commands into the Docker API. The engine is running on my machine. The engine happens to be running a container, and if that container is configured the right way, it can run Docker commands and talk to the same API. So the container can spin up multiple new containers. Now, I'm not laboring the point. I think you probably get it by now. The way it does that depends on using a bind mount, using effectively a volume. So the private channel to talk to the engine, either a socket on Linux or a named pipe on Windows, appears as part of the container environment, as effectively as part of the container file system. So let me switch to the real files and make it easier to view. So here's my Docker Compose in my infrastructure. Sorry, in my infrastructure. Here's my Docker Compose. Again, covered all this in the previous episode. Docker Compose, core files and the override files. So most of my definition is the same wherever I run it, but there are some things that are different between Linux and Windows. So I've got my core definition just here. It defines all the services, GOGs, registry, Jenkins. I'm calling the registry container registry.local, so I can refer to it using the same domain name inside containers and outside. So the DNS name for my container name is the same as I've got in my host name on my machine. So that's a neat little trick. And then my override files specify the bit to mount the Docker, the connection for the Docker engine inside the container. So on Linux, you see this pattern all the time. So don't be confused by what I'm saying here. This is not like a weird edge case. People do this for all sorts of automation tools because you can run things in containers from within a container. So it's just a volume that says var run docker sock on the machine where I'm running. So this is the Docker socket in Linux, gets mounted to the same location inside the container. And this is the default location that the command line expects to use. So just like when I mount a folder path, a directory path in my container file system, the application thinks it's writing to this path in the container, and actually it's just like a window into that path on the host. It's exactly the same with these private channels. So when the command line inside the Jenkins container is running Docker commands, it's talking to var run docker sock, which is a window over the socket on my actual machine. Windows, same principle, slightly different mechanism. So Windows uses these named pipes. So that's why I can't have exactly the same commands for Windows and Linux, because the actual location of the engine API is different on Windows. It's a named pipe, and this is how the path looks. But again, it's the same thing. So I'm just mapping this location, which is the default for a Windows container, from my host into my container. This is the expanded volume syntax. So the simple volume syntax in Linux, nice and easy. It assumes this is a bind. So this is a bind mount with the source and the target. If I need to specify a different type of volume, which I do here, so this is an end pipe, it's not a bind. So I need to have this type variable in here, this type attribute, sorry, and then explicitly specify the source and the target. Achieves the same kind of thing, but this is the expanded way of doing it. Okay, so let's go back to my book. Let's close this down. Go back here. So this is how it looks in Linux. This is how it looks in Windows, and that's kind of all the complexity of it. So the other containers, the Git server and the registry server, I'm not using volumes or anything like that. So this is not production grade infrastructure. Just showing you how it works. They're nice and simple. The only thing that makes Jenkins different is that it connects to Docker engine itself by using that volume. Okay, cool. So now the clever stuff then is that the CI process is just running Docker commands to do all the stuff. So when I run a Docker Compose build locally on my machine, the exact same process will run in the CI server. Not just the same process, but exactly the same input. So those Docker Compose files, those Docker files, they live in source code along with the actual source code. So when the build server is doing the Docker build command, I'm going to get exactly the same results as when I build it locally, which is another great advantage with the consistency, because developers tend to work in their IDE, right, which is fine. So if I'm a Visual Studio developer, so I hit F5, the application runs locally, I can check it all out, and then if it's good, then I make my changes, I push to Git. And then Git triggers a completely different workflow in my automation server that doesn't use Visual Studio F5. It does a whole bunch of other things, and the build fails. That's what used to happen in the old days. Nowadays, I hit F5 as I'm iterating over my new feature, but before I check in, I do the Docker Compose build and I do the Docker Compose up, and that just takes a couple of extra minutes for me to do a full-on smoke test using exactly the same build process that's going to happen in the CI server. Okay, so let's go and look at this Docker Compose file. So there's some nice stuff in here, taking advantage of some of the techniques that we talked about when we looked at Docker Compose in episode 9. So let's go back to my file list. What am I looking at here? My exercises folder, Docker Compose. So there's a couple of things in here. So we talked about having variables inside your Docker Compose file yesterday, in episode 9 rather. So this dollar curly braces means take the value from an environment variable on the host and use it and replace that. But the colon and minus sign afterwards means if there is no environment variable on the host called registry, here's the default value that you use. So what this is effectively saying is, when I run this in Jenkins, I will have set a value for the registry environment variable inside the job, which will be registry.local:5000. So my registry server, the configuration that I'm using, that's set inside the Jenkins job, but it filters all the way down into my Docker Compose file. If I'm running locally and just doing Docker Compose build, then I won't have that registry environment variable set, and it will use the default, which is Docker IO, which is Docker Hub. So I'm keeping the flexibility. So as a developer, I just do Docker Compose build, but I use exactly the same compose file in my CI process, which sets this registry variable, which then tags the image with the appropriate registry name to push it to a private registry. Okay, and then in the build file itself, so let me go back to my book and make sure I'm saying the right things. So these are the things here. So those registries, and the other part is the build number. So I should have pointed that out too. So the build number in here, I close this down. That's in the tag also contains another variable with exactly the same principle. So this build number is expected to be found as an environment variable on the host. If it doesn't exist, then it will use the word local instead of the actual build number. And again, this is provided by Jenkins, and there are environment variables. All the managed build services work in the same way. They give you some sort of environment variable which gives you the number of the build that's happening. So if that exists, then that will go into the tag, and if it doesn't exist, then it will become local. So I can tell fairly easily if this image came from a local build or came from the CI server, because that's part of the tag. It's clear where it came from. Okay, so that's how I'm using environment variables in my compose file and default values so that I support the developer workflow and the CI process. So that's that stuff there. Probably said I should have just read it out. It's probably more succinct than what I've just been through there. Okay, so Docker IO is Docker Hub, so that's fine. So when I build this locally, I will build an image with this tag. So it'll just be the Docker.io won't show up, so it'll just be called DIAMOL/ch11 numbers API, and the version number tag will be v3-build, because that's static inside the compose file, and then the -local at the end comes because I don't have a build number when I run locally. But when I run it in Jenkins, it will have a value set for the host. So for the registry, sorry, in the environment variable. So the domain name for the registry will be there, then the DIAMOL, and then the image name. And then if this is the second build that I run, it will be v3 build -2. So ideally, if your images are optimized so that only the layers change, the only layers that change between different builds are the bits with your binary changes in there, the small changes, because you've been and optimized everything. You can store every build you ever make in your local registry, or in your Azure registry, or your Docker Hub registry, because like the difference between build 1 and build 2 is only 2 MB. So you can store every single one if you want to. And having the build number in the tag, it makes it easy for you to find out where these things came from and track them back to the output in your automation server. Okay, so that's the important part of my CI setup. But the rest of the stuff is all in Docker Compose build.yaml, which tells Docker where to find the actual files. So again, going back here, again using override. So Docker Compose file that just specifies the two components that I'm going to be building or running, and the kind of the flexible way of specifying the image name, and a default environment variable which applies across the board. And then in the build override file, I've got the build stanza which tells Docker Compose where to look for the input for the Docker build command. So it's going to say in this build stanza, the context is numbers. The context is just the folder name. So from this current directory, the context is going to be the numbers folder. So it's always local to the path where I run the compose file, where I use the compose file. And the Docker file I'm looking for is numbers/API Dockerfile v4. So we know when we do our Docker image build commands, I can pass -f to specify the name of the Docker file to build. That's effectively what this does. And I always put a dot at the end so far to tell Docker the build context, the folder to use for the input is the local folder when I use dot. If it isn't dot, then I specify a folder name. This is how you capture that stuff in Docker Compose. So this just goes into the build stanza. I'm using an override file because I don't need this stuff to be everywhere. Like if I'm a developer and I want to see the projects and the default environment variables, I don't want to have to wade through all the build stuff too. This is only relevant when I build the image, so I put it in a separate override file. And there's another bit here. Again, if you saw the episode 9 about kind of advanced Docker Compose usage, I'm passing some arguments into my Docker image, the build number and the build tag, and that applies to all of my images. So I define it as an extension field here in my Docker Compose file. So this is consistent across all of my images, and then I just kind of merge that into each different definition with these double left angle brackets. So each of these images will have these arguments applied, and we'll come to build arguments in just a second. Okay, so that's the setup there. So my Docker Compose file has these kind of variables for the image reference that it gets built, and then inside the build override, it tells Compose where to find the input for each of the images that it's building, and some sets of arguments to get applied when the image gets built. Okay, so let me go ahead and do this, and I'll show you what it looks like locally. So let me open my my terminal again, and where am I now? I'm in exercises infrastructure, so I'll go back one directory, and now I am in ch11 exercises. So I'm in the right place. I'm going to build my images using Docker Compose. So Docker Compose, again, I'm passing in both those files. So the details in the build file will get added to the standard, the core definition. And so I'll get the full thing coming out, and I'm running Docker Compose build. And that's just going to run effectively the equivalent of a Docker image build command for each of my images that are defined in there. Okay, so this should happen fairly quickly because everything is run from the cache because I ran through everything before the episode went live. I believe it or not, I do a little bit of prep to make sure things work correctly. So everything came from the cache, and there's some interesting bits and pieces in here. So this arg build number equals 0, build tag equals local. There's some labels in here. These are some nice practices for when you're kind of getting more production-y with your Docker images, and we'll go through those in a second. But what I get here is it's tagged. It's created the image and it's tagged as. Can you see that? No, my head's in the way. So let's. I could move my head, but it'll be easier just to do this. So this is DIAMOL ch11 numbers API v3 build local. Okay, so it doesn't apply the registry domain name because that comes in an environment variable that isn't set when I run it as a developer on my local machine. It doesn't apply a build number because there is no build number because I'm building locally. So that's the output that I get as a developer when I do the build. And I see some of these pieces here. The other thing I can do is I can do a Docker image inspect. and look at the labels for one of these images that I've just built. So I've mentioned labels a couple of times, but only very briefly. Labels are just key value pairs that you can apply to all sorts of Docker objects, to images, to containers, to volumes, to networks. You use them as a management tool, really, to help you kind of track these things down. But you can also put labels inside an image, which work as metadata. So anyone who pulls the image, they get the container file system, which is the main purpose of the image. They get the startup command, which is part of the metadata, so Docker knows what to do when you run a container. But also any metadata that you put in the labels, they can see that stuff too. So if I do that's no good pasting that in there. If I do a Docker image inspect, and the format command there. So just like the Docker container inspect command that we've seen, the Docker image inspect would just splurge out a ton of JSON. By putting this format in here, I'm just saying, show me the labels part of the configuration, and then the image name is one of the images that I've just built using the Docker Compose files that we've looked at. Okay, and I've got 3 labels inside this image. The build number is 0 because it's not really as running as part of the build. The build tag is local because I'm just building it as a developer, and the version is 3.0, which comes from the Dockerfile. So those things are inside the Dockerfile, but I've got the ability to set them inside wherever I run my Docker Compose command. So inside the build server, I will set values for those. So it kind of flows through right the way from the definition of the build job, where I might set these environment variables for build numbers and tags and stuff. That flows through the compose file into the Docker file and then into the final image. So this with these arguments that get passed all the way through. So it's super flexible to do this, and it gives you a nice way of being able to say, oh, this image was definitively built from this job. So maybe images can be re-tagged and pushed around. So I can pull that image that's tagged V2 and I can rename it V3.1 and push it back up. But if somebody goes and pulls image V3.1 and looks at the labels, they'll see that it's really the V2 image. So it's a nice way of kind of putting the core information about how the image was built into the image itself that can't be modified afterwards. Okay, so those are the things we've just seen there. Okay, so even if you're, so this is the bit about using Docker Compose. Even if you've only got one thing, like if you're running a single container, I've said this in the past. Even if your app is one container, it's better to have a Docker Compose file with a single service defined, because that's the one place where you put all the parameters. You put the image name, you put the ports that you publish, you put the environment variables. So rather than have a Docker container run command in your docs, you just have the compose file, which is the documentation. And it's the same with the build. So all the bits and pieces that you can put into your Docker image build command. What's the name of the Docker file? Where's the path to the input? What am I going to call the image? You can put that in your compose file in the build arguments, and that just makes it super easy to manage these things without having to remember a bunch of options to put in commands. Okay. And then the new bits here, which we've seen the output of, this is how this stuff is defined inside the Docker file. So this label command is what applies the labels. So the first one is pretty simple. So let me undo that. Label version equals 3. So that's always going to be version 3. So imagine, as part of the build process, when we switch to a new major version that we're working on, we're just going to set this as being static because it changes so rarely. And then the build number and the build tag come from variables inside the Docker file. So this dollar and curly braces syntax means use the value of an environment variable. And I could set that inside the Docker file with the env command. So, env specifies the environment variable. I can refer to that inside scripts in run commands in my Docker file, but I can also refer to it in other Dockerfile instructions by using that dollar curly brace notation. In this case, I'm not using env to set those values. I'm using arg. And what arg does is it's kind of like the env instruction in that it sets an environment variable, but it only sets it for the duration of the build. So when you put an env instruction inside your Docker file, if I put env app version equals 3, then that value is available throughout the build. So I can see it in other Dockerfile instructions. I can see it in any scripts that I run. But it's also in the image. So if I ran a container and did a print env to look at all the environment variables, I would see that version equals whatever, because that's the reason for the env instruction, is to put an environment variable inside the final image. You also happen to be able to use it in the rest of the Docker file. Arg is different. It still sets an environment variable, but it doesn't get persisted in the image. So in the final image, I can't run a container and see these build numbers and these build tags. This is only available for the duration of the build. what I do in my build is I take those values and put them into these labels. So it's a long-winded way of saying that I can set this environment variable way up here in my Jenkins file, in my Jenkins build definition. It flows through the Docker Compose file, which sets those arguments in that extension field. And then that specifies the build argument that goes into the Docker file, which eventually goes into the label. So it's just filtering all the way down through. And at each of those stages, there are default values set. So the developer just does Docker Compose build with the build override file, and all the default values go in. And then in the Jenkins build, the real values get set as part of the Jenkins build or the GitHub action or whatever you're using. Okay, so the label instruction just applies those key value pairs. Again, I'm going through all this stuff and just paraphrasing what I carefully structured words from last year. But this is how the arg instruction works. You do see it quite a bit. It's useful to be able to put a value into the build process that doesn't persist in the image afterwards. Like people use it for, like, maybe the software you're deploying needs some sort of license key or something. You don't want that in the image afterwards. You only need it for the setup phase. You could maybe put that in an arg variable. Okay, so let's see this. So this is the bit I've already shown you. So I probably went a bit out of phase there. So the build number that goes into the argument, goes into the build argument when I do the build command. That comes in from a local variable, from an environment variable on the host that's running the command, or the default build number is 0, build tag is local. So when I ran it locally, that's what I saw inside my labels because I didn't specify any difference. Okay, and as it says here, I think this is the joke. This is the joke from this episode. There's usually one. The compose file shouldn't be too complicated unless you skip chapter 10, which was episode 9, in which case you go back and read it because it's, this stuff is useful. Okay, so that's the bit I've already kind of been through. And now if I go and have a look, let me see, this is my Docker image build command. So this is if I did it without Docker Compose. So let me open my terminal again. Go back here, clear this down. So where am I now? I'm in exercises, so I just need to go into numbers. Clear this down. And if I build this image, so this is the Docker file that's got those. That's disappointing. Let me go back up here. Oh, it went down a little bit. That's good. Okay, so this is the Docker file that's got those build args specified. So those args for build tag and build label. So if I can do a Docker image build command, the -f tells it where to find my Docker file. The dot at the end, the context is the local directory because I've just moved into that directory. And this is how you specify those values for an argument instruction in the Docker build command. So I specify a build arg option with the key, which is build tag, and the value, which is chapter 11. So this will flow through into my image and come out as an image label. Let's build that now, so it should be super fast because of the cache. And again, if I now look at my image labels, in this case, they'll be different than the previous one that I built. Because now I've got my build tag set of chapter 11. So you see the whole idea of capturing the arg inside the Docker file lets me kind of override the default value. And then in the Docker Compose file, I'm setting that value with whatever is in the environment variable. And again, if there isn't an environment variable, we'll use the default. Okay, so that's the output that we get there. So we'll have a different output in the labels from the build process. Okay, so let's go and close this down. As it says here, there's quite a few different parts to get some labels into an image. But the whole point of this, as it says here, this is an audit trail. So in my running container, I can always find out from the image, the labels, I can get the build tag, I can get the build number. I can always go back to the version of the source code that built the image that is my running container, which is actually really difficult to do without Docker. And you end up putting version numbers inside your binaries, which are potentially mutable, so you can't necessarily guarantee them. And getting enough metadata into a binary, which doesn't really have a structure to store metadata, is hard. So images make that super easy to have as much detail as you want. I'm using build tags and build numbers in here. You can put whatever you like in there. You can put your git commit hash, so you know exactly what version of the code built the running application. Okay, so writing CI jobs with no dependencies except Docker. So that's what I've been kind of doing. So we know about this from chapter 4, that you can use these multi-stage builds that have the SDK image and then package it into the runtime image. And this is one of the major benefits of using containers for your CI process. So all the kind of managed things, so Docker Hub does an auto build feature, GitHub Actions, Azure DevOps, all of them have a provision where you can spin up a build server as part of the service, which is just a VM that starts up in no time, and it's got Docker on it. So you can do all this stuff because you just need Docker to be able to run all these things. In this example, I'm using this Jenkins file, and we had a quick look at it earlier. I'm not going to focus on it too much. If you saw in the on the diamol.net website, there's a link there to the Pluralsight courses that I do. So Pluralsight is an online training platform. I've got a couple of courses about Jenkins that talk about pipelines here, and talk about plugins, which is kind of how you can kind of automate some of this stuff. And if you're not familiar with Jenkins, but you're interested in it, then that pipelines course is definitely one to watch, because it's a really nice way to do automation inside a container. So, I don't need to have a bunch of dependencies on a third party. I don't need a bunch of complicated kit. I can spin up Jenkins in a container. I can use these simple pipelines and get everything up and running. Okay, and then this bit here, so it calls into this shell script, which is build.bat, and the contents of that script, and again, this is all in the GitHub repo. That's what's inside that script. So it's just the same Docker build command that I've run locally. The only difference is the pull flag. So when you do a Docker image build or a Docker Compose build, it will use the images that you've got stored locally. So if I'm using an SDK image in my from line in my Dockerfile, if Docker sees I've got that image locally, it'll just use that image. It could be that the same image tag has a newer version on Docker Hub. So if I add the pull argument, it'll always pull down the latest version of the image, or it'll confirm that the version it's already got is the latest one if it is. So that's really useful, especially on CI servers, because things change. So you can find that even without, this is why it's really important to have a nightly build. If you only build your code if you only build your images when people change code, you're going to miss the situation where there's a change to the SDK image which breaks your build, because you won't know about that until a month later when someone makes a change to your application and the build fails for some bizarre reason, and you've lost a month of audit trail to be able to find out what happened. If you have a nightly build and you say, well, what's going on here? The build failed, no one changed any code. You can go and look at that SDK image and see the release notes, and maybe something has changed in the tool chain. So it's really important to be able to do that. Okay, there's a nice little trick there. So the reason why they're .bat files is that I can use the same batch files in Windows and Linux. So Linux, they just become executable script files. Windows will run them because they're called .bat. So in a non-cross-platform world, you wouldn't need to worry about that. Okay, so let's go and look at my Jenkins job. So the job should have already completed. We've already seen the output of this one, a part of the shell script. So the pipeline gives me this nice little view. I can see all these different stages. The test stage doesn't do a huge amount. All it does is it runs Docker Compose up, and I get a bunch of errors because I'm using an older version of Docker Compose that uses Python 2. So we'll just ignore that. What it does is Docker Compose up inside this test.bat file, starts everything. Then it does a Docker Compose list or a Docker PS to show that all these containers are running, and then it shuts everything down again. So really simple. This is just a tiny smoke test, but it proves the containers start and they run for a few seconds without failing. So if the container wouldn't start, then this step would fail and the build would fail, and I'd know why. In a real project, as part of this test stage, I would do the Docker Compose up, and then I'd run another container that ran a whole bunch of tests. So there's it would be more extensive than this little example. Okay, so you can see all these build logs in here. That's all the content that comes out from running the compose files. The stages of the script are all kind of fairly straightforward. The build stage just does Docker Compose build. The test stage does Docker Compose up. The push stage does Docker Compose push, which again, Docker Compose kind of wraps up most of the Docker image commands. The verify step is an interesting one, because all that does, if I show you what it looks like right here in Gogs, to prove this is where it's all coming from. So inside the CI, this is where all the batch files are, the scripts. Verify just does this. And it's a good habit if you're not used to kind of defining your CI pipelines right at the start, to print out the version of all the tools you're using. Because like if something weird happens and you're trying to track back and say, well, actually, like the promise of this from that guy I saw on YouTube is that it would work the same when I build it locally as when it does on the build server, but when I run on the build server, it's failing. This is when you track back and look at the logs and find that you're running, an 18-month-old version of Docker Compose, and on your dev machines you're running the latest version. So that's what's changed, is that you're running an older version of the tool. So by having this here as the first part you do in your pipeline, it's really cheap to do, because all you do is inside your let's go back to the console output up here. The first thing it does is it pulls all the code out from Git, which is fine. Then it runs my verify.batch file, and the output here just tells me the version of Docker that I'm running, which is 1903. and then it tells me the version of Docker Compose, which is a bit of an older one. And so that's why I'm getting some of those errors coming through. So this is a useful thing to be able to see because it's just an audit trail for the tool set, and that can help you track down errors later on. Nice and easy thing to put in. Okay, how are we doing? Oh, we're coming to the end. I don't know how many pages there are left. Okay, so we got one other thing to do here. So as part of the output in the final output in here, we push these things to my local registry. So the final push script just sends everything out to my local registry. And if I go and look at the links that are in here, this makes it super easy. I can just go and look at the tags for DIAMOL CH11 numbers web, and there's one tag in there which is my second build. Remember, the first build failed, but the job number still gets incremented, so this is build 2. If I kicked off another job now, I would get a build 3 output in there. And so I can do the same thing locally because I've got that DNS name in my host file. So if I do a curl and look at the API for my local thing, I've got a couple of registry repositories in there. I've got the numbers API and the numbers web. And again, if I go and look at just one of these to look at the tags to see what's been pushed. So if I look at the web one, oh, look at that. So let me try that again. So I'm going to copy this. And if anyone knows of a VS Code extension that can improve my copy paste game, I would appreciate it. Know about it. So that's the tag v3 build 2. So in the registry API, the list of repositories just gives you the kind of the grouping of the image name, and then the tags is an array. So every image that I tag and push, I would get another entry in here. Okay, so let's get this out and come down here. So what we're seeing is that's the output that I've just seen there. So there's a more extensive view of what a real pipeline would look like in the world of containers, because there's a whole bunch of other things you can do once you've got to the consistency of having container images that package your applications. So the early part of this pipeline is the same thing that we've just run. So the build, test, and the private push. I push these things to my private registry. So I've got a snapshot of the binaries. So I've got a potentially runnable version of my application from every build, as long as the build succeeds. And then potentially for a more kind of production grade pipeline, I'd have these extra stages here. So there are lots of tools that can do a security scan inside an image. So the image format is a public format, a public standard. So you can write your own tool if you want to, but there's a ton from the likes of Aqua Security and Snike or Snake, however it's pronounced, or Sneak. And they go into the container image. They look at, because the container image is really just a bunch of layers, just a bunch of zip files effectively. They look at all the binaries. They look them up against a bunch of vulnerability databases, and they will tell you if there are known problems, in the operating system layer or your application platform or the dependencies that you're using. So it's a super useful thing to have. Again, depends what your security posture is, because those are usually commercial tools. But if you want that level of stuff, you can put that into your verification stage. And you can also have like policy checks to make sure that only certain open source licenses are being used, or only certain base images are being used. So I've talked about golden images, where your organization might have its own curated SDK images and runtime images. This is where you would put in your pipeline to verify that only those are being used. Then you can put a digital signature on your image and then publish them to your public registry, or your production private registry. The digital signature bit means it's kind of traceable, that it was definitely created by this build, and the signature is like an approval that it's been through the test stage, it's been through the verify stage. Okay, so that's what that would look like. Docker's kind of coined this phrase a little while ago, the secure software supply chain. So again, it depends on how security focused you are, but you probably should be more than you currently are. This is general advice. People are worried about the source code that they're putting into their applications and all that sort of stuff, but there are several ways that you can be compromised. So this idea of a secure supply chain means that from your running container, you can always track it back to the source code that created that application, and the signatures of your images and the security scans mean that what you're running is what you think you're running, and that it's been proven to be safe at the time of deployment. Okay, so there's a bunch of stuff in here. Again, if you're new, all the exercises in the chapter, and again, this is a bit light on exercises this chapter, there's usually a bunch more. The exercises are things that you follow on through. There's a ton of text around them to guide you and explain what it's all about. The lab is something for you to do yourself. So there's some tasks for you to do in here, and a few hints of how you get there. And there's a sample solution up on GitHub. So I don't walk through those in the episode, because they're for you to consolidate your knowledge and put into practice the stuff you've learned in the chapter or in the episode. Okay, cool. So there's a couple of questions in here. So Iman says, do you have to worry about the security on your registry? Yes. So the sample registry that I've built here, it's HTTP, so it's not secure, and it's only on my local machine. I talked in a previous episode about how if you want to use an insecure registry, you need to specifically allow that in your Docker settings. So in my Docker desktop settings here, I've allowed that insecure registry. Normally, you would secure it with TLS. The later versions of the registry image on Docker Hub, which is an open source project that's maintained by Docker. It has authentication stuff in there as well, and it tells you how to set up all the TLS. So yes, ordinarily you would do that if you were deploying a registry server in a container within your organization. Then yes, you put TLS on top of it. It's fairly easy to do. You get your certificates, and you just include them in the you provide them to the container when it runs. So you can do it with a bind mount or whatever to include those certificate files, and then in your config you tell the registry to run in TLS mode. Okay. When Jenkins runs on a container, how can a builder container started by Jenkins access the source code cloned inside the Jenkins container? It's too late for me. It's too late in the day for me to work that out. Okay, so you were saying how do you get access to source code? Is I'm gonna take that easy question first. The way your Jenkins instance gets the source code is the way that any Jenkins server would get it from Git. So it goes and gets it from the golden repository. It goes and gets it from the source. How does how do you access the source code cloned inside the container? So I mean, you don't normally. So it doesn't. You're not saying I'm the Jenkins container. I've got the source code that's out on the host. Your Jenkins container is going to clone its own repo. So you see that in. I hope I'm answering the question that I think you're asking, which is like, where does the source code come from? If I go back to my Jenkins here and look at the output, the first part of the Jenkins build is it goes and pulls it from HTTP gogs. So this happens to be another container, so it gets it by the container name, but it does a Git clone effectively right at the start of the pipeline. Okay, so Iman says he's bought the wrong book and he's bought Learn Kubernetes in a Month of Lunches too. I'm glad to hear it. Read that one afterwards, because Kubernetes is a much, much bigger product. There's a lot more stuff in that Kubernetes book, and really you should be confident with Docker and containers before you move on to Kubernetes. But thank you for buying it. I'm going to go and buy this one. Yes, thank you. Yeah, and Arpit agrees with me. So he says he learned Kubernetes before Docker. It's not so fun. I completely agree. So we're coming at the end of this. We're winding up the chapter now because it's the end of it all. You're much better off getting a solid understanding of containers. Hopefully, this series is going to give that to you. Next week, if you're watching live, or from episode 11, if you're watching the repeats, then repeats on demand. Then we move into looking at orchestration. We're going to look at Docker Swarm because it's a ton easier than Kubernetes. And it's the thing that's built into Docker, so it's really easy to use. But we're going to learn about some of the patterns that apply in Kubernetes too. So next week, we're looking at orchestration. I don't know about you, but I'm going to look forward to my weekend off. So I hope you enjoyed today's episode. Let me switch back so you can see all the glory of me in my Friday dress down t-shirt. I hope that was useful. Thank you very much for joining. And yeah, so carrying on, we're carrying on next week. We're looking at orchestration. So we're stepping up a little bit more. But the big advantage of Docker Swarm is the way you model your applications. The modeling language is effectively Docker Compose. So you take your Docker Compose definition, and just like you can add bits in to represent the build settings, you add bits in that apply when you're running in Swarm mode. So next week, we'll look at a whole bunch of stuff around that. So thank you for joining. My name's Elton. This was Learn Docker in a Month of Lunches, and I hope to see you next time.